The rate of change of the altitude of a hot air balloon is given by this. Key to read slow and careful. Rate of change of the altitude. So you could think of it as, I have the altitude, so this is a Danica's chart idea again. The altitude would be the amount. Like, what is the altitude of the balloon? Then the rate would be a prime, the rate at which the altitude is changing. They gave the symbol R to represent the rate at which the altitude is changing. Which of the following expresses the change in altitude? So this is a fundamental theorem problem. So, let's see if I covered this up. No. So anyway, for fundamental theorem, the one I'm thinking of is this. If I integrate f prime, the time interval here is 0 to 8, I find how much f itself is different between time 0 and time 8. I find the change in f. So in this problem, we've got altitude is what we're talking about. So if we were to integrate the altitude's rate of change, that integral would be exactly the same as telling us how much the altitude changes during some time period. They're asking for the time period where the altitude of the balloon is decreasing. So here's my formula for the rate at which the altitude changes. Down here, when this rate is negative, that's when the altitude itself will decrease. So I use my calculator to find this time period when the altitude is negative. So grab my calculator. It's a little hard to see there, so I'm going to change the window. I only need to see a little bit of the y direction. So for y, we'll make the min just like -1, and the max 1. Now we don't zoom fit because we changed y. So we hit graph. And I kind of lost the whole picture, but all I really need to see is from here to here. So I can find those zeros. That's second, calculate, 0, and I got to find the left. It says x equal 4. I only need to go to about x equal 1. There's the left bound to x equal 2 for the right bound. Guess I just need to be somewhere in the middle, about 1.5, and it finds the 0. I don't really need to store it because the problem is not asking me to calculate anything. Just need to remember that that time right there is about 1.57, and they've got right there 1.572. So if I integrate from 1.572, and then I go find the other time, so I'm going to find this 0. So that's 1, 2, 3. So second, trace, find the 0. Start 3 is my left bound, 4 is my right bound, and 3.5 is a pretty good guess. Back to the problem. So this is about 3.5, and it turned out to be 514. So this will get me the change in the altitude between those two times. This would be 3.514 subtract A of 1.572. So A is the correct answer.